Hey guys, this is Patrick from STH, and today we're going to talk about the third generation Intel Xeon Scalable Ice Lake Edition naming conventions. Now this is actually a question that you may not think would be a big one, but it's one that we get questions on, I would say, a couple times a week. And specifically, we normally do a piece after our kind of main launch piece that is our SKU list and value analysis piece. So what I want to do is kind of have a companion video for that. We've been doing this for absolutely years. Probably 5+ years now, where we do these kind of SKU list and value analysis pieces. But one of the questions we specifically get is, how do you decode this whole Ice Lake Xeon thing? For a lot of folks that don't have a business where they review servers and benchmark CPUs and stuff like that, knowing whether the third generation Intel Xeon Scalable Platinum 8380HL is better than the 8380, or how those compare to the Xeon Platinum 8351Ns, it's darn confusing. Let's just call it what it is. And hey, look, with servers, we definitely don't get the easiest to pronounce names. In fact, I have videos and I get comments like this one that says, you know, the name is good when there's 4 cuts while pronouncing it. Because yeah, some of the server names are just these long strings that basically explain every single feature, but they have these just giant names that are really hard to remember. But the Intel Xeon Scalable definitely does not need to be that way, and it's a change that Intel made, and well, I'm going to help you navigate that. So we're going to talk a little bit about the names and then also some of the things that differentiate the Xeon Scalable processors, because this generation with the Ice Lake Xeons is particularly tough. All right, so let's start breaking this thing down, because we definitely need to start breaking down. Now, first off, the family name is the third generation Intel Xeon Scalable processors. Now, these are the third generation Xeon Scalable processors, but we always basically have to say Ice Lake because there was another portion of the third generation Xeon Scalable, which was the Cooper Lake. We have videos on both of these. If you want to see those, we'll link them in the description, but they're actually completely different parts. The Cooper Lake part was launched in 2019. It was really driven by Facebook, and it's basically a 14 nanometer part with 6-channel memory. It has some enhancements, but it's still limited to like 28 cores. It's very much like a kind of updated Cascade Lake processor, whereas the Ice Lake is a 10 nanometer part, and it has PCIe Gen 4, 8-channel memory. This is the much more modern platform. But both are still called the third generation Intel Xeon Scalable, which is why you basically always have to say whether it's Ice Lake or it's Cooper Lake, which just adds to the overall title and length of the title. Now, ever since 2017, when Intel moved away from the Xeon E5 era, they moved into the Xeon Scalable era with the Skylake Xeons. So we had Skylake, Cascade Lake, and then this like Cooper Lake, Ice Lake thing. And what we basically saw is that there's a base of 4 numbers that's in every single SKU. So in our example, using the Platinum 8380, the first 8 is a digit that tells us what model family it's in. Now we can have silver, we can have gold, and we can have platinum. And the silver is usually the 4. The gold can be either 6 or a 5, just to make it a little bit more confusing. The platinum can be 8. Now in previous generations, we also had bronze, which had a 3 as the first digit, but we don't have that in the Ice Lake Xeon series. And in previous generations, that difference in the gold series between 6 and 5, usually the 5 actually was a giant feature cut over the 6. And so I actually told people, I've called it, and literally to the Intel folks that are in charge of this, I said, you should rename that Pyrite, because basically the 5000 series of Xeon Gold processors, they're kind of not really, they don't have all the features of the 6000 series. And so it's kind of like when you go and you're going through like a gift shop and there's a little bit of pyrite and a little kid looks at it and says, hey, I want gold. Can I get that gold? And you look at the thing and it's like, okay, it's like $2. Sure, I'll get you gold. And you buy this thing. Kid thinks that they got gold, but they really got pyrite. They just don't know the difference. That was basically the old Xeon Gold 5. So really like the 5100 series was especially like that. And I said 5100 series because that second digit, in the Platinum 8380, where we get that 3, that's actually the generation number. So when we say third generation Intel Xeon Scalable, that's that 3. So when I said the 5100 series, that was the first generation, which is the Skylake generation. And then the last 2 digits are really the model designation. So 80 is basically the high-end model. You could say it's the highest end model, but frankly, there are other SKUs that are really like off-roadmap SKUs that usually go above 80. So I don't know what to really tell you other than that's the model designation. It loosely means that the higher your model designation, the better your part is. but that's not always true. So just it's a model designation. But what you're going to see, especially in the 3rd generation Xeon Scalable, is that we don't just have these 4 numbers. And that was very prevalent, by the way, back in the 2017 Skylake era. But in this Ice Lake generation and with Cooper Lake, we definitely see a lot of letters involved. So the first 2 letters we're going to talk about are H and L. So H means that it's a Cooper Lake Cedar Island platform part. So that's the one that launched in 2019 and we've done reviews on. And so that's a different part from the non-H, and the non-H is the Ice Lake. So if you have an 8380, that is Ice Lake, and 8380H is Cooper Lake. Now, because Cooper Lake was a 2019 part, there's also a L, which used to be the large memory letter. And so it used to be back in the day, and this is actually gonna be important for something we're gonna talk about a little bit. There used to be the standard SKU. So you'd have an 8280, you'd have an 8280M, which was medium memory, and then you'd have an 8280L, which would be like a large memory footprint. But in early 2019, because of competition from AMD EPYC, Intel said, we don't need the M anymore. We're just gonna lower the price of the L SKU to the M SKU pricing. We're still gonna charge a premium for it, but it's not gonna be anywhere near what it used to be. So a Cooper Lake part can have an H and an L, but we don't get the L on Ice Lake processors because the L is, well, it's large memory. And with the current generation of Ice Lake processors, AMD has gotten so competitive that Intel has basically had to abandon this whole, charging for a higher memory footprint. So all of the SKUs that you basically see are the large memory SKUs nowadays in the Ice Lake generation. But yeah, one of these major defining features is present in part of the 3rd generation Xeon Scalable line, but not the other part. I should also just mention that this is technically not an on roadmap SKU, but we did do a piece on the Intel Xeon Platinum 8321HC part. There you have H, so you know it's a Cooper Lake part, but it's actually a 26-core 88-watt part, which Facebook uses in their Yosemite. So if you go to like facebook.com and you are, see like a front-end web node is like serving you data, there's a good chance that that's actually done on one of these 8321HC parts. And I think the C there means custom. I know that there are a ton of people that say that Intel's high core count CPUs also use a ton of power, but that's a pretty good example of where that's not necessarily true because it's a 26-core 88-watt TDP part. But when we look at the SKU list, and hopefully we'll flash this up here, this is the overall SKU list, and you're gonna see the Cooper Lake parts, they're in their own section, and then there's like all these different little buckets that Intel has, because what Intel really did with this Ice Lake generation is they started adding a whole bunch of letters, and sometimes the letters mean something pretty significant, and other times they are consistent, and sometimes they're not consistent with each other. Sometimes they're just there, and we have no idea really why there's that designation, but there are a lot of letters. The first letter, and one that we've definitely used in the lab, is Y. Y basically means that you have Intel's Speed Select technology Performance Profile 2.0, which is the SSTPP. And that feature basically allows you to go and dynamically configure, like, okay, so I can put a single SKU in there that is one of these Y SKUs, and I can kind of select the type of performance I get out of that. So I can say, I want more clock speed or less, or they have, versions of this where they have like different cores and stuff that you can select. So you can get like more cores, but lower clocks. And the idea there is that you can spec a line of servers with a single SKU, and then you can change the number of cores that you get in that system based on what you need in that particular server. So that's a really cool one. There's an N, which means it's a networking optimized SKU. And a lot of times what you see with these is that there's a lot tighter of a variance in terms of the turbo boost. So in fact, Intel actually does some turbo boost tuning as an example to make sure that you don't get too much jitter, because when a processor goes from a low clock speed to a high clock speed, that there's a little bit of latency and jitter that you can get in that process. So the networking guys don't like that. And so that's something that is in the N SKU. There's also something else that it replaces that we're going to get to later, because this gets really confusing, but that's basically N for networking. That one makes sense. P means that it's an infrastructure as a service cloud specialized processor. Well, yeah. V though means it's a software as a service cloud specialized processor. So we have P for infrastructure as a service and V for software as a service. And oh, by the way, there's only one P SKU and one V SKU that are publicly listed for those. So they're a letter that basically just has a specific SKU on it. So I don't know why we need a letter, but that's what it is. There's also Q, which is optimized for liquid cooling, although you can totally go and get liquid cooling solutions for the, say, 8380, even though it does not have a Q. But Intel has a specific liquid cooled optimized SKU because why not? Then we get to something that I think is ridiculously confusing, and it's the M SKU. So I remember I just talked about the fact that there used to be a medium memory SKU. So if you had a first generation or second generation Intel Xeon Scalable processor, there was an M, which meant that you had that kind of like medium amount of memory that you could potentially configure in that for that processor in that system. And now M means media processing. Which is just kind of weird, but that's what it is. T basically means that you have a higher T case and also extended life support. And Intel does definitely have these parts that are really kind of like for like embedded type of applications or industrial applications where you expect that these processors are going to be deployed for a long time. And so there is a kind of T SKU, and we've actually tested the T SKU versus non-T SKU and basically saw the same performance when we did I think it was like the 4116 and 4116T. But it's definitely something that Intel's been doing for years, and it totally makes sense. So this is one that I totally get. There's an S, which stands for, I don't really know, but basically I think what it means is that it has the maximum SGX enclave, which is up to 512 gigabytes capacity. That's basically the best I can give you for the S. But if we go back to the overall SKU list and we go up to that 512 gig, the maximum Intel SGX enclave capacity, 512 gig, what you're gonna see is that those two S SKUs are joined by three other SKUs that don't have S's. There's one with the Q SKU, which is our liquid cooled SKU, but then we have the like 8380, which has the 512 gigs, but doesn't have an S. I really don't know why we need an S, but I guess, maybe somebody's getting paid by the number of letters that are out there. I don't know. And then finally, we get the U. Now, the U basically means that it is uniprocessor, so single processor, which means that you get basically the single socket only parts. So on the AMD EPYC side, this would be like a P series processor where, if you have a P at the end of the SKU, you get a discount for a given core count and clock speed, but you can't run it in two socket servers. You can only run it in a single socket server. The kind of weird thing there is that even though there is a U for the uniprocessor, one of the three, or a third of the uniprocessor only SKUs actually doesn't have the U, it has an N instead. So yeah, that's really confusing. So on the single socket side, the Platinum SKU that is single socket optimized, which is the 8351N, that is a single socket only networking SKU. But then the lower end, because we go from Platinum to Gold, the Gold, what is that? The 6314 and 6312 Us. Those, even though they're Xeon Gold, they're not networking, but they're also single socket only because they have a U. That's really confusing, I know, but that's just kind of how they do it. And at this point, I want to pause and just talk about the Scarecrow. Now, you might be wondering, what about the Scarecrow? And hey, why did that Scarecrow win the Lifetime Achievement Award? And the reason the Scarecrow won the Lifetime Achievement Award is because it was outstanding in its field. That was the dad joke for this video, but what is not outstanding in their field is the people who come up with all this naming. This is ridiculously confusing. We get questions on it all the time, and I really wish that Intel just took some time to say like, okay, this whole naming thing is just ridiculous. Let's get back to basics, make it simple for folks. Let's not see how many characters we can possibly use to define our SKUs. Let's make life a little bit easier. And the reason for that is actually important, for us especially, but for a lot of people in the industry. There are so many people that rely on these processors that having to write out things like third generation Intel Xeon Scalable Processor Ice Lake takes a lot of characters. Think about how much of humanity is wasted just typing out all of these, giant product names, right? Why do we have a Xeon Platinum when all of the features are different between the Platinum SKUs? I mean, it's insane that that's even a thing anymore. Now, we definitely have given this feedback to the teams, and there are multiple teams within Intel that deal with all these kind of brand names and stuff like that. And I definitely know those folks. So if you are watching this and you know who you are, if you are watching this and you're responsible for it, is think, I want to be a Scarecrow and be outstanding in my field of naming product. Now on the STH main site, we're gonna have a link to the article in the description of Eric's SKU list and value analysis piece. But and in there, we actually go into things like saying, hey, we have little charts that kind of show like, okay, this is how you get the most cores and most like say cores and clock speeds for a given, price point. This is, where you're paying the most for a core or least for a core and all that kind of stuff. But one of the other tables that Eric made, which I actually really like in this generation, is he kind of looked at some of the extended features of the Ice Lake generation. I think there are at least 5 features that he has on this chart that are really relevant to anybody that is looking at servers because they're really important. The first one is the number of UPI links. Now, UPI, if you don't know, is basically, think of it like the link between if you have 2 processors or more than 2 even, but multiple processors that are Intel processors in a given system, like you have a dual socket server, there's a UPI link that goes between the 2 different sockets. Mainstream high-end parts, we typically have 3 UPI links that go between the 2. And the more links you have, the more bandwidth you have between the 2 sockets, and so that's generally better. Now, it used to be that the Xeon Gold 5000 series used to have only 2 UPI links, whereas the higher end parts had 3. But nowadays, all of the Xeon Gold and Platinum have 3, whereas the Xeon Silver has 2 UPI links. So there's not as much bandwidth in a Xeon Silver platform between the 2 sockets as higher end platforms. The SKUs that we would exclude from that, of course, are the single socket only SKUs because they don't need that feature. And not only do the UPI links are they only 2 for Xeon Silver, but those UPI links actually run at the older 10.4 gigatransfers per second instead of the higher speed 11.2 gigatransfers per second that the 3 UPI link configurations for Xeon Platinum and Xeon Gold run at. Realistically, in some of the Xeon Silver, it probably doesn't matter, but there are people who actually spec Xeon Silver and have spec Xeon Silver for like GPU compute nodes. And there you could run into an issue where if you're starting to do a lot of, like GPUs that are on one socket to GPUs that are on the other socket or something like that, that UPI bandwidth can be a big issue. And so just something to keep in mind. The other one, which is completely inane, and I really wish that Intel just stopped doing this, is they actually have different DDR4 speeds. So although the headline feature is DDR4 3200, there are a number of SKUs that just don't use that high-end DDR4 3200 spec because they're using like DDR4 2933 or 2666 or 67, depending on how you round. And the kind of challenging thing is that it's not necessarily only like the Xeon Silver SKUs that are using the 2666 speeds. It's actually even up to like Xeon Platinum has lower speed than DDR4 3200. So it's just something that you have to look at if you're purchasing a Xeon Scalable processor system. Like if you're buying a CPU or comparing 2 different CPUs, I would definitely go check the memory speed because that's another area of differentiation that I think really matters. And if you're wondering, like, could Intel have DDR4 3200 on all of their chips? The answer to that is yes. The memory controllers can totally do it. They're not making brand new types of memory controllers for all of these different chips. They're just locking the speeds out at certain speeds. And so it's just kind of like one of those things that like, I think Intel should just say, okay, we're just going to support the top bin. And if you want to go put lower speed memory, go for it, but we'll support all the way up to a level. The AMD EPYC CPUs, for example, that's basically what they do. And then also things like the ARM, so the Ampere Ultra CPUs, they do the same thing where they just say, okay, well, we're going to support DDR4 3200, but if you want to go lower, the systems will actually boot with like 2933 in there. And while we're on the memory side, all of these have 8-channel memory, but most of the CPUs can actually support the Intel Optane Persistent Memory 200 or the PMEM 200 series DIMMs. There is like kind of one area that I guess it's maybe not so clear. In the Xeon Silver, you generally do not get Optane PMEM support, which is kind of a bummer. I mean, like Intel, you want to sell those Optane DIMMs. It raises your server ASPs, especially on the low end. But there is an exception to that, which is the 4314 part, because that part does support Optane PMEM 200, while the rest of the Xeon Silver line doesn't. And that includes the higher end Xeon Silver 4316. And so that's just like kind of crazy to me, right? Like the higher number SKU doesn't support it, but the lower number SKU does. The last feature I want to talk about is basically called the Max SGX Enclave. And if you don't know what SGX is, the basic idea is with confidential computing, there are a lot of like cloud service providers and a lot of organizations that run virtualized hosts want to have securely encrypted virtual machines. So that way a client or somebody running a workload doesn't have to worry about, a malicious actor running in a VM attacking other VMs on the system. That's kind of really the genesis of the whole idea. And kind of what you can see in this column is that you basically have 512, 64, and 8 gig max enclave sizes, depending on the SKU, but it really, it's not necessarily a straight thing like where the Platinums are all 512s and the lower ones are like 8. It's actually kind of just a total jumbled mix. And I think that's just really annoying. AMD, by the way, does not do this. So they just basically say, hey, we'll let you go and use our trusted computer or secure encrypted virtualization and our other trusted computing platforms without these types of limitations. So, I kind of think that kind of is like some artificial SKU differentiation that Intel's doing. It's just annoying. And I'll give you a really good example why. So let's say you had the Intel Xeon Platinum 8358. P, which was our infrastructure as a service part that we talked about earlier because we have that P. Now, if you did that and you deployed those and then all of a sudden, a year or two down the road, you say, oh, actually, now I know what confidential computing is. I think we can use it. I want to use SGX. Well, even though you have a Xeon Platinum part, you're limited to an 8 gigabyte SGX enclave. I mean, just imagine if you were infrastructure as a service provider, you deployed these things in your infrastructure all over the place, you're running things on there every day, and then you realize, oh, I need 9 gigabytes, or maybe I need 12 gigabytes or 32 gigabytes, something like that. Anything over 8, and all of a sudden you're like, well, I have Xeon Platinum. Why am I stuck with this? And it's just kind of like one of those things that especially since it's a newer feature for Intel, in kind of the mainstream line they've had in other products, but really in kind of the mainstream server line, I just wish that they just said, okay, we're gonna go give everybody the Mac, and so people can start adopting our technology. I think that would be a way better way to go do this. But Intel's like on this road to just go create all this weird artificial, differentiation in their SKU stack, maybe so they can just have more SKUs and more letters. They say that they're being designed for specific markets, but frankly, a lot of these changes do not require major silicon changes. They're basically just tuning parameters that you could do in BIOS. And while you may think that sounds absolutely crazy, frankly, the ARM guys and AMD, that's basically what they're doing. So everybody is, the response to basically Intel doing this is that they've made a lot of channel partners say like, hey, cool that you're doing this, but it gets really confusing at some point. So the kind of, upstarts, or I don't know if you can call like AMD an upstart or ARM an upstart, right? But those companies that are really coming at it from a different angle, trying to get into Intel's big market, they're saying, hey, we've heard the feedback from Intel's customers that this is too confusing. We're going to make it simple. We'll let you tune it however you want, but we're just going to kind of sell you a base processor. I think that's a way better model. Now, we're not going to get into all of the value analysis, why the 6334 line is like this 8-core line that's been running for years and super high dollar per core because, well, it's a high frequency, low turbo boost type of processor. But at the same time, what I really want to do is just kind of focus on a key concept that a lot of people miss, and we do get a lot of questions on. And that is that Intel's SKU stack, the numbers do not necessarily mean, like a higher numerical number does not necessarily mean that you get a better processor. So just because you have a higher number doesn't mean you get more cores and a higher clock speed. It could mean, well, the exact opposite. It also doesn't necessarily mean that the higher number has a higher price. The lower number parts could have a higher price than a higher number part. So it's really hard to just go by the numbers. I think what Intel's really doing is they're trying to have some semblance of, as you move through the different generations from first generation, second generation, third generation Intel Xeon Scalable, that that person that's buying the 6134 8-core part buys a 6234 8-core part, and then now is buying the 6334 8-core part. Well, that's hard to say. But, at the same time, I think it's also really confusing for folks. And so I wish that Intel, kind of had maybe some better strategy for naming or for numbering these things anyway. Hey guys, I know this was not a normal review, but we get this kind of question all the time on STH. So I decided, let's just go make a video. So that way we have the folks that read Eric's main site piece plus the folks that are on YouTube, and everybody just knows it. If you want to, you can always share this article or this video because, well, that's a good way to go tell others without having to actually tell them. And hey, if you did like this video, why don't you give us a like, click subscribe, turn on notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.